We're going to finish up the problem that we started last time with the summing of integers and computing their average. Then we are going to move on to showing you how to use TopCoder, which is an environment that we're going to be using both in class and lab throughout the rest of the semester. And finally, we're going to be spending a bit of time talking about command line arguments, Argv and Argc. You'll notice in the notes today there's also string streams, but we covered that extensively in CS102, and I consider that to be review material, so I do not plan to cover the material on string streams in here. I do expect you to look at it because you are going to be dealing with string streams in lab. So look over Dr. Plank's notes on string streams. They're on the second half of the args command line arguments. Make sure that you are comfortable and familiar with it. You are always free to ask questions if there's something about it that you're unsure about. Okay, so if you remember at the end of last class, we had you there we go. We had you writing a C++ program to read integers from standard in, sum them, and print their average to 3 decimal places. That was the code that I wrote for doing it. So simply using that while loop idiom of reading until cin fails. And in this case, we were assuming the input data was all integers, therefore it would succeed. Also, I declared sum to be a double to ensure that when I took the average that I got floating point division rather than integer division. Finally, in the printf statement, you see average equals %.3f. That said that I wanted the average to be printed to 3 decimal places, and I did not care how wide the field was. So to fit it in a field exactly wide enough to accommodate the number that was computed. Also, while I had a LF there, that is not necessary. It turns out that %f works with both floats and doubles. Whenever you pass a float to printf, it simply promotes that float to a double before it gets passed to printf. In this course, we want you to use doubles, not floats. The reason is that floats give you less precision. A double is supposed to have 64 bits of memory. A double is only got 32. I believe a float is defined by the standard, the C++ standard, gives you 6 decimal digits. And a double gives you more than that, roughly in the range of 12, although I think not quite that. Okay, so that was the program you had to do. Now, what I want you to take a few minutes to do is to modify your program so that it eliminates bad input. Okay, in fact, what I'm going to do is move it so those of you who are moving quickly can also do the final part, but we're going to do it in stages. And the first thing I want you doing is the first bullet. Modify your program so that it eliminates bad input. Okay? I'm going to give you about, say, about 7, 8. I'm going to give you about 8 minutes to do that. And what you need to do is simply rewrite this program, and you're going to have to rewrite that while loop. It's not going to work like it is because if the input's bad, it would immediately drop out of there. And therefore, you're going to have some bad inputs, more than potentially one bad input. So you might have a file, say, that looks like, let's say the input was 6, Brad, Foo, 8, Charlie, Joe, 7. You need to take the average of 6, 8, and 7 while discarding the Brad, Foo, Charlie, and Joe. So your program has to keep going even after it hits that first piece of bad data, it just discards it, moves on to the next piece of input. So it adds all the good integers in the input, discards all the bad input. If you get done with that, move on to the other points in there. So take, like I said, about 8 minutes. I'll give you till 9:55 on that. And if you have a question, feel free to raise your hand. Feel free to work on it with a partner. If you don't have your laptop, please do it on a piece of paper. It's let me try to upload it to the website, okay? I'm just going to take a moment. I'm going to try to upload this. I just had a request if I could somehow make both the program and the instructions available. I'm going to try to upload the program to the website. Okay, so if you want my program to modify, if you can read that, I'm not sure if you can at the back. It's web, if you type web.eecs.utk. Yeah, just a second, I'll put that on the PowerPoint slide. Put my code up there, so if you want to modify it. Okay, I'm going to go over the solution. I realize that many of you may not have finished. The point and part of this is to get you to think about it. If I just showed you the answer, then I don't think it would be as effective as forcing you to spend some time trying to figure out how to do it. And this is going to happen in lab too. Not all of you are going to finish the TopCoder problems that you do in lab, especially the second one. You shouldn't get all discouraged by that. A lot of it is just getting you to think about things and turn it over in your head. And people proceed at different paces in their programming. There's a wide variation in how quickly people program. So if I kind of gave you enough time so that everyone could finish this, well, some of you just don't code that quickly, and it might be half an hour or 45 minutes or longer. So in this class, I'll often terminate it, and you may feel, geez, I just couldn't quite get it. But just thinking about the problem before I go over the solution, I think is very beneficial. So in this case, the way I did it, and there's multiple ways to do it, is I introduced a flag called moreinput, which was going to be true as long as there was more input. And you can see I modified my while statement. That's the big change here, is I then, inside the while loop, I read my data. So the first thing I did was check, did the operation succeed? Did the read succeed? If the read succeeded, it was a valid piece of input. It was an integer. And I could do what I did before, which is add that piece of data to the sum and increment count. If the read failed, it could fail for one of two reasons. The first reason it might fail is because of end of file. So all the input might be valid, but at some point I'm going to reach end of file. And if I reach end of file, I can check it using the EOF function. And with it being end of file, I set more input to be equal to false. Okay, because there is no more input. Okay, can someone tell me what would be an alternative here? An equally good way to have done this? Yes.
I did a do while.
Okay, okay, that's okay. Actually, just right here. I'm going to ask that in a moment, so that's a good, but you're ahead of the game. In this else statement, there's something else I could do rather than set more input equals false. Yes?
You could break.
Very good. I could have broken right here. So instead of doing it this way, it would be equally good if I had just put a break statement. And in that case, I presumably would have just up here written while true. So I would have put it into an infinite loop. And then when I got down to this statement right there, I would have broken out. I actually like to do it this way. I know that there's a lot of professors in this department who don't like it done this way. They don't like using break statements to get out of the loop. So in this course, you often won't see me do it this way. Personally, I think the break statement is there for a reason, to provide a structured way out of a loop. And if a language designer provides it, you may utilize it. And I think it's actually the cleanest way to get out of there. I actually very much dislike having to set more input to true and then do it this way. I think it actually obfuscates the logic. But I'm in a minority on that. And if you do this in other courses, you'll probably get points taken off. Therefore, I'm going to try to hew to the format that most professors in this department prefer. Okay? So, at any rate, that means you set more input to false rather than breaking out immediately. So, if the CN statement failed and we haven't reached EOF, the final conclusion, the last logical conclusion, is that the input must not have been an integer. So in that case, we need to clear CN, and in addition to clearing CN, we also have to consume the input, which I do by declaring a string variable named consume input. Remember, I said try to use meaningful variable names, so that's what this variable is doing. It's being used to consume input, therefore I named it that. And I read that in as a string because I can read anything in as a string, and that operation should succeed. So once I've done that, I have consumed the bad piece of input. I'm ready to go back to the top of the loop and read my next piece of input. So that's the key. Everything else is just as it was in my original program. So it was just this modification to the loop that was needed to be changed. Now, I'm actually going to move on at this point and show you the answer to the second one. I think what I'll often do is kind of give you a basic thing and then something for those of you who finish quickly, something additional to do so that you're not bored. And in that case, what I wanted you to do was modify the program so that it stores the numeric input in one vector and the non-numeric input in a second vector. And the reason for doing that is so at the end of the program, not only could I print the numeric average, but I'd also print the sum of the numbers in a field 6 spaces wide, and I would print the bat input at the very end. Now, strictly speaking, I didn't need a vector for the integer input, but I was doing it just to give you some practice there. So the answer to the second problem looks as follows. In fact, I did not bother to save the integers in a vector. There was no reason to do it. but I did create a vector for the string input. And nothing much changes, actually. The while loop is still very similar. The only modification in the while loop is I add a statement that adds my bad input to the string vector. So in my else statement where I consume the input, I actually push it onto string input. So string input dot pushback. So I'm accumulating all the bad input in a vector. Okay, so just that one additional statement there. Then at the end of the program, I actually need it to print out the sum. So sum equals, I said printed in a field 6 characters wide, so it would be %6d, and the sum, whoops, never mind, I was doing it up here. Print average equals %.3f, then the new \n forces a new line right there. This \n forces a new line. Then sum equals, that's bad, %6f. I had to print it out as a 6, but I should have done it as %6.0f because I was printing, I did the sum, I declared it as a double. Therefore, I had to print it out using the F option. I wanted to print it out in a field 6 spaces wide, and there is no, they were integers, so there should be no decimal point. Then I printed bad input, and then I simply iterate it through the vector, and I printed out the strings left justified in a field 20 characters wide. And how do we know it's left justified? I put a negative sign. Do you see after the % and before the 20 there's a negative sign? That says to left justify my output in a field 20 characters wide. Does anyone else see another interesting thing about that printf statement?
C string.
That very good. That C underscore string. So printf is unable to print a C++ style string. It needs a so-called C style string. Remember, C++ evolved from C. And there are still some artifacts of C embedded in the C++ language. One of those artifacts is that printf is incapable of printing a C++ style string. You have to give it an old style C string. The way that you can get an old style C string from a C++ string is with the C underscore str function. So if you're going to print a C++ style string with printf, you'll need to extract the C style string using C underscore str. This should not be new to you. You had to do this in 102 as well. Does anyone remember from 102 why you sometimes needed to extract a C style string in 102? There was a situation.
When we type the name of the file, CS.
That's right. So when you opened a file in 102, you also needed a C style string. That was the second situation with the open method for a file that you needed a C style string. So there's a few situations, we will point them out as we go along, where you need C style strings. Okay, so that's the solution. I will post this code after class so that you can look through it at your leisure, and if you need to, you can use it in the lab as well that's due tonight. It might help you a little bit. Any questions about this code? Yes?
That's like basically exactly how I wrote mine.
Mm-hmm.
And, well, when I run it and say I type like 3 strings in there,
Mm-hmm.
it prints the last string twice, and I don't know why.
Okay, so the question was, I wrote it essentially like I did, but you said that yours printed the last string twice. So I'd have to look at your code, but somehow what you were doing is you were putting the test for the EOF before you did your read statement. Okay, I have to look at your code, but I know for a fact you put your test for EOF before your read statement, because remember, EOF is reactive, not proactive. So if you've reached the end of the file but haven't attempted to read yet, it will return false, saying you haven't yet reached the end of the file, and then you'll do your read, and it's like, gotcha! It's I really was at the end of the file, sucker, and you end up with the same. It fails. It leaves the old value there. So that's what happened. I can look at your code later, but I know you did that. Whereas if you look at my code, notice I did the read first. I tried to read it. And if the read failed, then I checked to see if the reason it failed was due to the EOF.
I put while not cn.eof.
Okay.
So
that is what went wrong. See, you put the while not. So what your code was, so you did that while not cn, oh wait, while not cn.eof. And sure enough, what happened is, when you got to the end, it still, even though there was no more input, it didn't realize that, so it returned true. You came in here and you read it, and that's when it said, ha ha ha, gotcha. I failed, left the same value, and so you ended up processing it twice. So you got to really, basically, you should never have this EOF statement in the while. It will always get you this way. It's totally annoying.
I did it because I remember thinking while true is bad.
Mm-hmm. But like I said, I don't consider it bad. The way you have to kind of handle it is with that silly boolean flag, which people love. My theory is when I came, and most of the professors came up, it was in the 1980s, and break statements didn't exist. And we were taught, oh, go-tos are bad. You have to use structured programming. It's bad to exit a loop anywhere other than from the top of the loop. And so we were taught to create these flags and set the flag to false. And then when you come back to the top, the flag is false, and you drop out, and it's all nice and structured. And I think it's all BS, because I think it just complicates the logic. So in this course, if you like, you can write while true and use break. You just need to kind of need to also learn that Boolean flag idiom. Okay? So you said you did it with a do while.
Yeah.
So actually, just let me get out of here before I destroy this particular program, okay? Because let me copy it. So there are other ways to do this. And I'm just going to take a couple minutes to see how other people might have done it. So you used a do while. Okay, so you said do. Okay, and then what did you do? Also kind of a read like this, or?
I did the if cn, but then I didn't have check for it in the file because my while was while not in the file.
Okay, so you didn't do this check right here. You took it out. Okay.
Because it's a do while.
Okay, so you put down here, you put the while, and you said while, okay, not cn.eof.
And I guess that works because checking out the middle is not the beginning.
Okay, so actually try putting a string at the end. I bet you also had the double read appearance. Okay, I think this has the same issue, which is, let's say that you have a single, just one piece of input, okay? So you read it, and you add it to data, and then you come down, and it's while not cn.eof. It's still not EOF after it reads there's one piece of input. It reads it, but it's not yet EOF. So it comes back up, and it will try to read it, and it will fail the second time. Now, yours works. Actually, now I see why yours works. Yours works because it now goes into the else statement. It clears and consumes it. The cin again fails a second time. But it's okay that it failed because you weren't going to do anything more with it. So you kind of covered up the fact that you had one additional iteration in your loop. Okay, it still actually was iterating one too many times with your do while, but that else statement kind of cleaned up your mess, so to speak, and hid the fact that there was an issue. Now, I think if you had added the vector and you had done the pushback and your last piece of input was bad, I think you would find that you're getting the same word printed twice at the end. Be interested at the end of class if you can come up.
That's true.
Okay, okay. So it does do that. Okay. Did anyone else have another way of doing it? Yes.
I used to go to.
Ooh, okay. I'm not going to allow you to share that solution, okay? Use a break statement rather than a go-to, okay? If you use go-tos in the lab, you're going to lose points, okay? Yes.
I used to while like not end of file, but then I put a if end of file in.
Okay, so that works. So the gentleman did do a while not end of file, but then put another check. That's fine.
Yeah, because it's like I can't do like while cin into that because if it fails it goes out the while.
Right, exactly.
Like,
Yep. Now, so that was fine. What you did was fine, but you needed that second check in there. Anyone else? Yes,
I
Keznia.
also use cin data for end of file.
Okay, so you said while
While
cin.
data
Okay, you said while cin into data
for
or not cin.eof. Okay, so but what happened?
and then I have cin fail and else
But this will fail. But what happens? It seems like the first time. Just a second. So you would do it like.
and then I have if else and if failed I do clear and then into the
Okay, but the problem is if it fails, you'll immediately fall out of this while loop.
you won't because it's an or statement. It needs to be called.
Oh, you're right. You're right. You're right. Okay, so
It's not
you
end.
you're right. Okay, you have a very clever solution that's also a little bit subtle. So I'm not going to go over it.
Works.
You're right. It
I
works.
use it in my lab and
That's fine.
it worked too.
It works. You're right. I totally agree it works. I know what you're doing. I'm not going to go over it because it's subtle. Okay? Very good. Your solution does work. Okay? So I'm just going to... Actually, should I? No, the reason is because I'm not going to go over your thing. It's easy for someone looking at it who's looking at your code to not quite get what's going on unless you comment it well. This is a situation. It's a good solution. You should comment that kind of code very carefully. Okay? It's a beautiful piece of code, but you need to comment it because someone looking at it quickly, like I just looked at it quickly and thought surely it won't work. And then I realized on reflection it does. That's the kind of code you need to be careful to comment. That's a very nice solution. Okay, so this code works. Okay, you have to first check to see whether it actually failed. So you have to reverse it. So you have to actually say if cin.fail, cin.clear, consume it, else you do that. I think that's roughly how you did it, right? Yep. So that way works as well. And the advantage, the reason I said Keznia's code is beautiful, there's no extra Boolean flag in there or a break statement. Okay? But it's also subtle. So what's happening, because I do like it, if you fail with cin data, then it still checks the OR statement. And if you haven't reached EOF, it says, okay, it failed because I had bad input, therefore I can continue, and I go into the while loop and I say, if I failed, clear it, consume the input, else it was a good piece of information. So she has a beautiful way of writing that while statement that I did not think of, and I wouldn't think many programmers would, but it's a beautiful solution to it. Okay, I'm actually going to pull the plug on further comments about this code because I want to move on and go into TopCoder. And I believe most of you at this point have gotten TopCoder to work. If not, it appears what you're going to have to do is register with a name other than your UTK account. So you'll have to register with something like a Gmail account or a Yahoo account or whatever, a Comcast account, and go from there. So that should just take a moment. What I would like you all to do at this point is to actually take a moment and try to work through Dr. Planck's palindrome problem. So do it just like he did, and you don't have to mess up every time. He was intentionally messing up a few times to show what happened, but again, with your lab partner, I'd like you to go through and work the problem that he did with palindrome so you get a feel for how it's done. And Alan and I will be around to help if you have problems with it.
So his notes at the beginning had the old website on them, so just be aware you can go to
My notes, which have the new website. You may have to hit refresh, Alan. So my notes have the new website with the TopCoder showing up, and then you have to go to Challenges, TopCoder Arena, and it should bring up the Java. Your cache is out of date. If you're coming up with Dr. Planck's old site, it means your cache is out of date. You have to somehow get rid of the old cache. One thing, this always bites me. Listen up, okay? This is important because it's bitten me already twice, even when I knew it was there to bite me. So it says choose SRM 564, okay? Well, the thing you want to do, at least what I want to do, is say, it's between 561 and 576 here, and I go and I choose 564, and it's the wrong problem. So their numbering scheme is not what you think. When you actually look at the SRM, you'll see the SRM number is different. So in order to get SRM 564, it's actually way down here in the 849 to 860 range. Okay? And I have 2 times now out of 3 blown it and chosen the wrong problem. So make sure when you download the problem, we always give you the name of the problem. Make sure the name of the problem matches the problem we told you to do, and if it doesn't, go back and re-download it. Okay, so give you to about 10:35 on this. With it in lab tomorrow, so we just wanted to get you started on it. It would help if you have a few minutes. If you didn't finish Dr. Planck's example, if you're able to, before lab tomorrow, finish it. If you can't, well, then you'll have to kind of just get started tomorrow. There's going to be 2 problems tomorrow in lab that you'll be working on, and from now on, that's what you'll be doing. So tomorrow there's a question called Fox and Word, and then there's a second one, distance between strings. that you'll be doing. So you'll work on TopCoder for about an hour, then you'll switch over to the lab. Now, we're in an unusual situation here in that some of you, last semester in 102, we did go over command line arguments, but most of you have not seen command line arguments. So, we are going to go over them very quickly. You are allowed to pass arguments to a program. And when you do at the command line, so you're allowed to do something like type, say, I've got a program called homework. I might give it 368. Those are called command line arguments. Those are arguments that I want passed to main. And C++ has a standard way that you tell main that you're passing it arguments. And that is, you declare that main has two parameters. And you have to follow this template precisely. So the first argument is an integer, and it's the number of command line arguments that you pass to the program. The second one is essentially an array of strings. But that's not what you see here. What you see is actually an array of C-style strings. And you might say, how do I know that? Well, you often see this written as charstar Argv. Now, if you remember, you don't put the size of a vector in your parameter declaration. So what this is really saying is we are passing it an array of char stars. Well, a C-style string is a pointer to a character array. So a char star, we'll get to this in a few weeks, a char star is a pointer. The star says it's a pointer. You don't need to worry about that right now, okay? You can think of this as an array of strings, but you have to write the declaration either like you see it here, char double star argv, or alternatively the way I wrote it is char star argv. So you are getting an array, in this case, of 4 arguments, even though it looks like you're getting only 3. So in position 0 is always the name of the file, which in this case is homework, HW. Then in the remaining entries are your command line arguments. So your command line arguments actually start at argv1. So argv1 is where your arguments start. argv0 contains the name of the executable, which in this case is HW. Even if you pass in numbers, they will come into your program as strings. Okay? So you will get your all command line arguments arrive in your program as strings. And if you enter n command line arguments, then argc is going to be equal to n plus 1 because it puts the name of the executable in argv0. Okay, so you always start looking at argv1 for your command line arguments. Okay? And Dr. Planck just had a short program to show you how you could print the command line arguments. All he's doing is he is iterating through a loop. While I is less than argc, he prints out the command line arguments. So it's very easy to get your hands on those command line arguments. Now, 2 issues with them. First of all, first issue 1 is they're a C-style string, and you really want to treat them as a C++ string. So what I do, and I suggest you do as well, is to convert a C style string to a C++ string, assign the C style string to a C++ string variable. So for example, let's say the first argument was the number of rows in a picture file, because that's what you'll be doing in Lab 2, is you'll be dealing with picture files. Okay? So if that first argument was supposed to be rows, what I would do is declare a variable like, say, string rows, and then I would just assign argv1 to it. And that will automatically convert the C-style string to a C++ string. Okay? So you can always assign a C-style string to a C++ string. And therefore, I think the easiest way to deal with those command line arguments is to assign them to C++ string variables. The second thing you need to do is, in this case, if it's a number, you really need to convert that string to a number. Does anyone remember from 102 how we did that? How did we convert strings to numbers in 102? String stream. So to convert a C++ string to a number, remember there was something called an I string stream. Okay, we often called it a buffer. And then you would stuff the string into the buffer using the string command. And then I'll call it int numRows. If I want to read it into a variable called int numRows, I can now say buffer greater than numRows. And that will convert the string to a number. Just one second, okay? You can check, just like with cin, you're allowed to check to see whether that operation succeeded. Okay, so you can write, you could say if, for example, not buffer into numRows. I know I need another paren there, but I don't have room. You could print cerr bad rows. Okay, so it works much like cin in that you're allowed to check for bad input, which is something you'll have to do also in Lab 2, is check to make sure that the input the user provides, the command line arguments, follow the expected types.
What's the difference between I string stream and O string stream?
Okay, good question. So I got it. The question is, what is the difference between an I string stream and an O string stream? Okay, and the difference is this one is used for input. So this is used to convert, is used to extract stuff. I'll say elements. Elements from a string. And this one, an O string string, is used for output. Okay, we're going to use it infrequently, but you use it essentially to format, is to take several variable values and combine them into a formatted string. So an iString stream is a bit like cin, and an OString stream is a bit like cout. So with an OString stream, you might see something like, say I had declared an OString stream as out. Then you might see something like out get set w 6 left name, say set w8 set precision 2 fixed, say weight. Okay, and that would produce a formatted string, except that instead of writing it to the console, it creates a string and puts it into OString. And then if you wanted to get that string out of there, you could write something like string str my string equals out.str. And now what it does is it takes the string that was created by that output operation and assigns it to my string. So OString stream essentially allows you to take several variables, combine them into a formatted string. iString stream takes take a string and explode it into several elements. Okay, so that should be enough for you to get started with your command line arguments, which is something that you'll be dealing with in Lab 2, which you will start tomorrow. Yes,
How do
quickly.
you feel about AY?
I feel that you should not use it in this class. It's dangerous. I'll tell you, if you come up quickly, I'll tell you why. Okay, do not use A to I.
You even use A to I because
If you
well because the